Welcome back to the Evergreen Building, College of Southern Idaho, my classroom. And this is our first in the series looking at specific minerals. I did the first video on mineral properties or physical properties. So if you haven't watched that video, maybe start there because that provides a good context and framework for what we're going to do as we feature some select minerals moving forward. And again, the whole goal that I have is focusing on the minerals that are most common, the ones you tend to see in rocks, because when I get to the videos on the rocks, that's what I really want to concentrate on, is to help out folks that are out on their own little adventure, looking at things, help them be able to identify what they're seeing. So the first one here we're going to do is on quartz. Some thoughts about quartz before we get started. Quartz comes in a lot of different varieties. It's one of the most common minerals on Earth. And as we'll see here, there is a lot of discrepancy on some of the names of the varieties of quartz. So things like agate and jasper and flint and chert and chalcedony and onyx. I am not a rock hound, someone who collects these mineral samples, these rock samples, and then polishes them to make jewelry. I don't have that skill set. I'm not hugely interested in that, although I think it's really awesome that people do. And so going to the internet was actually even more confusing. And even when I've talked to rock hounds, I mean, one person's agate, someone else calls flint or jasper, and I've never found a rhyme or reason to any consistency to some of the definitions I've heard from other folks. And so what I decided to do for this series, just to keep it simple and just keep it uniform, was I went to, I guess for geologists, what we could call like our dictionary, this nearly 800-page book, the Glossary of Geology, with the super fine print here. And there's more geologic terms in here than you can shake a stick at. There's probably hundreds, if not thousands, of mineral names, landform names, so on and so forth. So I went with what I found here when it came to some of the terms that I'm going to use today. I'm going to start with just an overview of quartz and its properties, then get into a little bit of the varieties of quartz that we see, and then I'm going to show some rocks and how quartz manifests itself in rocks of different types. So let's go ahead and get started, and we'll start with my fun little sheet here. So quartz is nothing more than two elements, silicon and oxygen, put together. Excuse me. Sometimes when we have it in this combination, this is called silica. So if you ever hear someone talking about volcanoes or igneous rocks in terms of low or high silica contents, it essentially fundamentally refers to, I guess, how much quartz is there. Or there's lots of other minerals that have these two ingredients as part of their makeup, but they have other elements as well. So quartz is just silicon and oxygen put together. It's the second most abundant mineral in Earth's crust. It's incredibly common. The first most abundant are the feldspars, and we'll do a video for sure on the feldspars. When quartz is very pure, it's colorless, but when we get little impurities of it, that gives it some color. I'll show you that here in a few minutes. We talked about cleavage planes last time. Quartz has no cleavage planes, so if you just whack a piece of quartz with a hammer, it will tend to break randomly. We call that just fracture. So it does not have any pre-existing planes of weakness within it in terms of its atomic structure that would guide how it forms or the shape that we tend to see. Let's see what else. Quartz is incredibly hard. It's actually harder than most metals. It scratches glass. It's 7 on Mohs hardness scale. It's incredibly durable. Excuse me, not just physically, but also chemically. It doesn't tend to break down into secondary minerals, unlike some of the feldspars. And so it's incredibly robust, and this is one reason why quartz is the most, it's incredibly common on Earth's surface. If you've gone to a beach, most beaches, not all, but many beaches, the sand, if you were to pick up the sand and look at it closely, it's dominated by quartz. Same thing in most river systems, the sand that you might see there. So it's just incredibly common and a great mineral to I'd be able to identify and understand as best you can. So let's look at some of the varieties of quartz. So quartz in and of itself can, these are just a couple: amethyst, rose, milky, smoky, citrine, tiger's eye. These are all just different colors. Tiger's eye is just a quartz sample that'll have some banding to it, but one area that reflects the light a little greater, so it kind of looks like an eye, like a little shinier zone. There's a fancy term for that. It's called chalcodont, or I can't remember. A fancy term that I just forgot, but you could look that up. The other types of quartz we see are chalcedony, which is cryptocrystalline quartz, which means the quartz crystals themselves are very, very small, microscopic. According again to the glossary of geology, and using some of those as our resources here and our arbitrary classification systems, two types of chalcedony are agate and onyx. Agate tends to have sort of irregular bands. It can be any color. So there's specific types of agate like moss agate, lace agate. Again, rockhounds have names for all these sorts of things, but it's not necessarily consistent, at least from what I can tell. Excuse me. Onyx will have more like linear type bands running through it. And then chalcedony in general kind of has a waxy kind of luster, often kind of lines the inside of rock cavities. This is the type of material you might see inside a geode or lining a thunder egg, which is a filled in geode. We'll talk about some other varieties as well when we talk about rocks. So if you're like wondering at this point, well, like what about jasper and flint and opal or some of those sorts of things? Those are actually considered either rocks or mineraloids, and so we'll talk about those later. So let's look at a few examples. Here's a nice piece of pure crystalline quartz. This is actually quartz crystal. If you look at the bottom side of it, you can see the hexagonal shape. So this is the actual crystal shape that quartz crystals tend to form in, are these hexagonal shapes. There's the base of it is a hexagon, and then it's terminating upwards here by my finger in a crystal point. But you can see it's colorless. In this case, it's also transparent. The light passes through it clearly. I can see my finger tapping the other side there, just like a sheet of glass. So there's a piece of colorless quartz. Some more colorless quartz as well. Again, these are crystals, but crystals are rare, right? So you're typically not going to find a lot of quartz that looks like this. Of course, there's smoky quartz, kind of brown. Amethyst quartz here, the purple. This is more typical of, this is also kind of, this is a little bit pink. This isn't my best one. It doesn't look as pink as I thought it did earlier. But that's rose quartz there. And this is milky quartz. This is probably more typical of what you see with quartz, is this sort of texture and look to it. So notice we do not have crystals here, a little bit of yellow in it as well. But you could test it to see if it scratches glass. So this is quartz. Some of you might be wondering what quartzite is. Excuse me, I'm getting over a cold. We'll look at some of that when we get to rock types. And let's see what we have here. We have some agate, or excuse me, jasper. So jasper tends to be this kind of reddish color. This is actually a piece of jasper from Idaho called Bruno jasper from the southwest Owyhee Desert. So this specific type of banding and pattern that we see here. But a lot of this kind of cryptocrystalline quartz, it tends to be kind of reddish in color with oxidized iron, is what we often call jasper. Here's a piece of agate. This is, I think, what a lot of folks would call a moss agate, kind of a cool bluish color. You can see the light penetrating a little bit here. So it's a little bit translucent to some degree. This one's been polished, obviously. There's sort of the grungier side on the back. But agate with some of the banding and irregular banding, right? Here is a piece of chalcedony. This is sort of classic chalcedony here, kind of white, creamy color. A lot of these concentric little bands here running through it. And again, sort of cryptocrystalline quartz. So this is often found lining the inside. Excuse me, I'm going to show you, I think I could have here's one that's pretty good. A geode that has some of that chalcedony on the inside. So you can see the inside of that is lined with that material. And so this would be, we'll talk about this in a minute, but this would be hydrothermal quartz, where it's actually silica. It's in solution, it's moving with water, hot water, and then it's precipitating out in some cavity or void in the rock. Here's a little bit of opal, this is sort of common opal. This is not, what you might see at a jewelry store in terms of precious opal or fire opal with the play of colors here. But this is just, actually this is kind of a little different than quartz. It's actually the same chemical makeup, silica, but actually has water in it as well. It's hydrated silica. So a couple samples of opal. And now let's move on to what does quartz look like? Let's start with igneous rock. So just a couple facts here or fun things to kind of focus on. So in igneous rocks, when we have magma or lava, quartz is often the last mineral to crystallize. So usually it gets stuck in whatever space is left. So we've got other minerals that form nice, well-developed crystals. But then once the quartz is starting to form, it's just forced in whatever space is there. And this is why, again, quartz crystals tend to be not completely rare, like valuable, but they're just less common, right? So space is at a premium in some of these rocks. And so the quartz tends to fill in the spaces between other crystals that have already formed. When we look at quartz in igneous rocks, even though we see it over here as transparent in a lot of cases, or at least translucent, light is actually penetrating it to some degree. But remember, once it's inside a rock slammed up next to other minerals, it's actually going to have some of the light's passing through it, but there's also minerals up against it. So it's going to tend to appear kind of gray, but you should still be able to get a sense of at least its translucency. It probably will not look as transparent. It's going to look a little more gray and maybe kind of waxy or kind of glassy in terms of its luster. When we see it in veins or some sort of layer in igneous rocks, a lot of times it's white. And this is why a lot of times geologists take the little hydrochloric acid bottles out into the field, is white lines going through a rock. Sometimes it's hard to distinguish quartz versus calcite, and so we use something like that to test that. Okay, let's look at igneous rocks. Let's look at some igneous rocks and quartz in igneous rock. So here is a nice, I would call this a pegmatite. So this has the shiny stuff here is muscovite mica, which will definitely feature in another video. We'll do a video on the mica family. The more grayish to yellow material, pretty much everything else in here that's not mica is quartz. So we've got some smoky quartz in here forming the rest of this material, okay? So that's a nice example of quartz in a igneous rock where the crystals were very large. It was able to grow very large masses of, in this case, muscovite or quartz. Here's a classic granite. We can see the pink feldspars in here. I don't see how well the phone can zoom in. That's pretty good there. The individual, let's see if we can get something to point with. That would be better than my ugly finger. There we go, little pen. So the pink feldspars, potassium feldspar, some of these little black shiny pieces here are biotite mica. And the quartz in here is this more gray material that's kind of like a little bit translucent in the background. This is the quartz material in here. So we can see that, again, it's filling in some of the spaces in this crystalline rock. The tricky part here is, of course, the crystals are very small. Even in intrusive igneous rock where the crystals are large or larger, they're actually pretty small still. They're pretty squished. Let's see, is this one, how instructive is this one? This is another granitic rock. Again, we'll try to get the camera. There we go. This worked pretty good. Some of the quartz in here. Again, some of the biotite. Might be a little bit of hornblende in there as well. I got another rock here. Oh, the quartz shows up beautifully here. You can see these gray blobs in here of quartz, and this more fine-grained. This is kind of grading into more of a rhyolite here. Here I have a piece of pumice. So we'll get to this when we get to rocks, but it has a lot of holes in it. And if we zoom in closely, good job, iPhone. Well done. We can see some of these individual quartz crystals. Now in here, there's so many bubbles that these crystals aren't slammed up next to, another nice one right here. They're not slammed up next to other crystals. And so we can see the more colorless appearance of the quartz in here, and more of the transparency versus the translucency that we saw like in the granites and some of those other rocks. So yeah, I'm digging this. This is good. And then what do I've got left? This is a nice piece of rhyolite from here in southern Idaho. Let's see if we can stand it on end. Oh boy, we'll just lay it flat. That's pretty good. And let's see if I can pick out, they tend to look, if you rotate it in the light, you might see some kind of shine. These lighter colored things here, these are definitely feldspars. But it looks like, yeah, there's like a little bit of quartz right there, I think. Let's see. Doing this with, I need 3 hands really to get this. Yeah, so there's a little bit of quartz in there. This one's a little bit trickier. Boy, when I move my head out from behind the camera, I can see it a little bit better. That could be a little bit down there. Going right there. Anyway, rhyolite, very fine-grained rock, difficult to see in there. Okay, moving on. How about the sedimentary rocks? What do we see there? Well, in sedimentary rocks, quartz is going to show up a lot of times as grains, either sand-sized grains. If it's really fine-grained, it's going to be silt or clay-sized. You probably won't be able to see it as well with the naked eye. You'll need some sort of magnification. If it's a conglomerate or breccia, if it's gravel-sized, big chunks, you'll definitely be able to see it. So remember, quartz is really hard. It's resistant. It beats up other rocks. So if there's a bunch of particles moving in an environment, maybe down a river or in a sand dune or at the beach, anything that's quartz rich is going to tend to beat up any softer rock. So the quartz tends to get more dominated in an environment with every collision and with every movement of the sediment. And that's why, again, at the beach, most sand that you see at most beaches is quartz. So it's going to make up lots of grains. There's actually a sedimentary rock that we'll get to later called chert, which includes varieties like jasper, which is usually kind of reddish. We looked at some of that already. And flint, which is kind of an outdated term. At least I think so. It's usually a dark colored chert, but sometimes you see these somewhat synonymously. But we'll look at this. But this is totally made out of essentially silica or cryptocrystalline quartz, this stuff called chert. So it's very hard. People like my friend Chuck get really excited about it because you can make this into tools. It's flint knapping. It's stone tools, arrowheads. This is what native people used to kind of survive in the world. So look at a couple sedimentary rocks that has quartz in it. So here's a big, I can zoom back out now a little bit, a conglomerate. This is a Cambrian conglomerate from northern Utah, and we can see these large golf ball sized gravels of quartz, and really fairly pure quartz as well. This looks a lot like the milky quartz I showed you earlier. You can see some kind of rounded particles in here. I just grabbed this one. This is a much younger conglomerate, not nearly as sort of clean, but this also has, if not quartz in it, at least some quartz-rich rocks. There's actually mostly probably quartzites in here. But you can see a few of those in there. Here's a breccia, so angular particles in this rock. Again, these are all quartz. If you weren't sure, you could use the acid test because there's a good chance this could be calcite from a marble, something like that. And then I'm showing here 5 different samples. These are all sandstones, different colors. But what's interesting is, and again, you can't see because the sand grains are going to be too small, but every grain in here, or most grains in all of these sandstones, because I've looked at these under a microscope, are dominated by quartz. You can see there's some variation though in color. The variation in color tends to be the cementing agent. So in this case, dominantly how much iron oxide is cementing the quartz grains together, and sort of what state of oxidation that iron is in is what's giving you this sort of red to brown to pink to kind of a speckled reddish brown in that case. And even this one's, I don't know how well this shows up on the camera, this one's got a little hint of green in it. I don't know how well that shows up. So sandstones in the sedimentary world. In metamorphic rocks, quartz often forms as bands in some of our high grade, meaning high pressures and temperature rocks. And then there's even a rock dominated by quartz, which is called quartzite, which is basically a quartz-rich sandstone that's been squeezed and heated so that the quartz grains are actually fused together. So with a sandstone, I can actually oftentimes rub off the individual grains, or if not, it feels sandy to the touch, like sandpaper, because I'm feeling the texture of each individual grain. When we look at something like a quartzite and we rub that, it tends to be much smoother. And the texture here in a quartzite, we'll spend time on a quartzite later, but kind of looks more sugary. So this is dominated by quartz. Here's quartz in a metamorphic gneiss, so it's forming the light colored bands in the gneiss there. So again, quartz is in all three rock types, in common ones at that. These are both very common metamorphic rocks. Of course, conglomerate breccia sandstone, very common. And then all the felsic, meaning they're silica-rich igneous rocks. So granites, pumice, rhyolite, that sort of thing. And then the last thing I have here is quartz often also forms veins. So the trick here is you can get quartz, like a lot of other materials, you can get it in solution, you can get it dissolved and able to be transported by water if you can get the water hot enough. And a good analogy I like to use with my students would be if you have, maybe you're a coffee drinker and you want a lot of sugar in your coffee, so you put some sugar in your coffee and you stir it, but some of it dissolves, but a lot of it's at the bottom. So you've got the sugar at the bottom of your coffee cup. Well, how can you get that sugar completely dissolved in with the coffee? And one way to do that, as I'm sure you know, is to get the coffee even hotter. So if you can get that liquid hotter, that will allow more sugar to be dissolved in the liquid. And the same is true with minerals. If we can get groundwater, in this case, to be very hot, usually in a volcanic environment or maybe at depth, then that allows the groundwater to carry more mineral material in solution. Ultimately, it can carry it to some environment, maybe a cavity in a rock, maybe it's filling a fracture in the rock. And then as it starts to cool, it starts to precipitate. So it starts to deposit that mineral material in that cavity or in that fracture. And if it's filling a fracture, it's making a vein. So here we have a igneous rock with a quartz vein cutting through it. So this would be an example of that kind of process there. And so you'll often see these white stripes cutting through the rock. This is not a dike because it's not igneous material. It's not a mixture of minerals. In this case, it's one specific mineral, in this case, quartz. So this would be a vein. Dikes are formed by magma injected into fractures. Veins are formed by fluids, groundwater, moving through fractures and then leaving behind a mineral deposit. So that's all I've got. Hopefully that was helpful. A little quick rundown on quartz. I'm making this up as I go, so hopefully it's helpful. These are obviously a little bit longer than the field videos, but I'll try to, as best I can, keep them to about 20 minutes or so. I'll do a couple more. I think there's maybe 5 or 6 or 7 other minerals excuse me, I'd like to focus on. I don't want to do 30, 40, 50 different minerals. I don't want to get into ore forming minerals, which I know will disappoint some people. We're not going to get into bornite and chalcopyrite and sphalerite. That's just not my niche, and I don't have as much passion in that arena. But we'll definitely look at some more of the more common minerals, and then I'd like to transition into rocks, because that's mainly what you good folks are going to encounter when you're outside on your adventures, or maybe you're looking at your rock garden in your house and you're like, what the heck did I collect? What is this stuff? Hopefully we can give you some tools and some knowledge that will help you moving forward, and then you'll be the little local rock expert in your little world, and people will bring, like they do to me, all sorts of things and ask you if they're meteorites or dinosaur bones or all the cool stuff that I sometimes get to look at. So hopefully that's helpful. Again, glossary of geology, if you want a very large, fat book in your collection and you want to, I guess if you learned a new word for the day with the number of words in this book, I think you'd probably expire from this earth before you get through them all. But you could try. There's a lot of cool words in here. So there you go. All right. Thanks so much, and appreciate all your help and donations and just supporting the channel, and onward and upward. Thanks, team.